research on bears for a long time. What was it that got you interested in the first place?
I was a very happy hippie living on the shores of North Kootenay Lake, boat access only homestead. I built my own boats and I had bears in the yard all the time, and I was following bears whenever I could. That was pretty fascinating. And then I also had a burgeoning desire to possibly be a wildlife biologist. I was like in my 40s, and so I went back to university. A bear project started up in our region, and I sort of volunteered myself to do a project for them, and they took me on. My calling card was I was good in the wilderness. I said, I can come back after you send me out for a week. And they said, that's good enough for us. So I got started doing the DNA method on bears. It ended up changing my life. They put me in a helicopter the next year, and I had to do a DNA survey over 4,000 square kilometers where I'd pick out little sites about the size of your kitchen over this huge landscape and try to lure bears in to get a hair and a DNA fingerprint and then find a pattern in nature. And that was the switch that turned on in my head. Oh, I'm being paid to find a pattern in nature when it looks impossible. It was the ultimate puzzle, and I was hooked.
A lot of the work that you do is about identifying corridors. We're talking about how bears move from one habitat to another. And maybe you could explain a little bit about how that works.
Grizzly bears 500 years ago sort of moved everywhere. They had sort of a one big continuous population in North America, and they have really large home ranges and they interbreed over large areas. But then European settlement occurred, and slowly we've caused a lot of bears to sort of be extirpated. Bears used to go to Mexico, and now they just go to just south of the Canadian border into the US. And a part of that process is a bunch of people moving in and living in all the valley bottoms with their highways and houses, as we do, and I live in one of those. Slowly we would kill the bears who came in and got in conflicts at chicken coops or beehives or whatever it might be. And that pattern over decades slowly fractured the bears into these isolated populations. Sometimes the populations are big when you have a highway network, but sometimes those highways end up creating what we'd call a small population. And if it's cut off the breeding between those populations, it creates a very high conservation risk for the bears in that area. And that's what was occurring in the southern Selkirks, where the Darkwoods property was, and Nature Conservancy of Canada had bought that property. So it became sort of the front lines of conservation for grizzly bears in the area. So once we figured that out, what we needed to do then is to try to fix that. And so we went in at radio-collared bears, and we tried to estimate where those corridors were. But we're estimating something that isn't there. We want to find where bears move. So I always used to say we're out trying to find a ghost. We're trying to find something that's disappeared. So we radio-collared bears, modeled their habitat using the data from them, where do bears go versus where bears don't go. And then we used that to predict where bears should probably cross. So it turned out that our modeling to estimate corridors was pretty good because the male bears were still using those areas. We had some confidence that it might be true. And we had predicted a corridor to link the southern Selkirks to the Purcells. And there was one male bear pretty far away. And sure enough, he made himself over there and he got right into our corridor. And that opened up a whole arena. We thought, oh, well, let's start radio collaring in and among and around that corridor. And then from then on, we started finding the problems that bears were having, why and how they were dying. So we implemented management to reverse some of that mortality risk, and that worked. And 15 or 20 years later, we have bears moving across, surviving to breed, and reconnecting that population.
So a lot of people are surprised to learn that the bears in the interior are really focused on huckleberries. People often think of bears, they think of salmon, but in the interior is a different story. Maybe you could explain how it is that a tiny huckleberry can really be so important to grizzly bears.
Around the world, bears focus on several different very important foods. It's salmon, sometimes on all the coastal areas, British Columbia, Japan, Eastern Russia, and then in Southern Europe, it's acorns. What they need is a food that produces a lot of energy to store fat. They just need something that can be converted to fat. And a lot of the year, when they come out of the den in the spring, their foods are roots, shoots, and leaves. And you try to get overweight eating radishes and lettuce, and it's really hard. So to put on weight, they needed sugar. They have a digestive system that's very similar to humans. One of the reasons they tend to get in conflict with humans is because they like our foods, and that is simple to digest foods. And sugar is readily converted to fat. That's what helps them get through hibernation. They give birth in hibernation, and they have to live till the next berry season starts, which starts in July. So they eat berries like crazy from July through September, hibernate, give birth, come out of the den, and eat radishes and lettuce until July again. They have 3 months a year to get all those calories in there. And it's surprising that a big animal eats a little food. Well, whales, they're the biggest animals on the planet, often specialize in krill, little shrimp that are smaller than your hand. And it's just a matter of eating all day and having concentrated food supply. So when we started modeling huckleberries, we found huckleberry plants everywhere. You can't walk in the Kootenays and not run into a huckleberry plant. But what we found out with bears is they only use the best producing huckleberry patches where there's enough concentration of food that they can eat a lot in a 24-hour period, and then they can do that over 2 or 3 months. So we were looking for, and Darkwoods happens to have a lot of, concentrated huckleberry patches.
Your research has really been useful in helping us manage Darkwoods, and one of the things that it's been doing is helping us inform our road deactivation program. Maybe you could talk a little bit about roads and how they impact bears.
Around North America, the perceived relationship between bears and roads is sort of a big topic, and it's been shown in a variety of ways that roads are what bring people into the backcountry, and people sort of kill bears for a variety of reasons. And so I got involved in trying to identify where the very best huckleberry patches, the most important food for the bears there, and then seeing how those habitat patches and the bears' use of them related to the mortality risk that comes from people on roads. So we did a 15-year experiment on that and got a lot of good data. And we found out the punchline was that when these huckleberry patches were close to a road, within 500 meters of a road, the bears weren't using them. And that was really, in essence, sort of habitat loss. And we measured like 38% of the best huckleberry patches in the region were near roads and were not being used. So it really explains one of the reasons that roads are so bad for grizzly bears. First, they get killed on roads. And second, they're not utilizing the food that's right near those roads. So it's sort of a double whammy. And the best way to manage that is to not close all roads or anything, but just to close strategic roads around the best habitat patches. And that's where our partnership came in. You guys own the land and controlled it and wanted to manage for grizzly bears. So it was sort of a match made in heaven.
Indeed, and we went ahead and deactivated several hundred kilometers worth of roads as a result of that. And there's large swaths of Darkwoods that you can't get to. I've never even been to parts of it because the roads have been deactivated for so long.
Well, I went back in to do some work a little while later, and it is a pain because I could hardly get to some of those places. But you know what? We thought, this is good. It's important to leave some roads for people to use. There's historic use of them and let people use. But we have so many roads that there is plenty of room to minimize the use of them. And it benefits everybody. Other species like elk, there's been some really good papers about the same relationship between elk and roads as there is for bear and roads. They don't get the nutrition of the food near the roads, and it lowers the elk population. So it has bigger implications beyond bears, and that's sort of the fun part about science, is to the cross-generation or the fields.
So when we first met Michael, it was deep in the Darkwoods. Roads were everywhere, and that was about 15 years ago. Maybe you could talk a little bit about how it's changed quite a lot since then, hey?
Yeah, I met the Darkwoods area in the late 90s, and that was like 30 years ago. We were doing some really early research. There was a lot of roads, and it was cut over. The timber harvesting company had been harvesting healthily, and so I got to see it 30 years ago and then watch its metamorphosis over time. And then when the Nature Conservancy bought it, some of the roads were closed, but also the timber management was very different. Mainly you're growing back the forest. And we immediately started seeing all manner of things you don't normally see on a road. Bears breeding in the middle of a road, very unusual. I thought, okay, this is a different place now. Moose walking down the road, big, huge bull moose, and we'd have to sit for 20 minutes until it got off the road. But we knew something was different, and it's pretty cool. And when I first started, it was really hard to catch a grizzly bear because there weren't that many around. And then eventually it got a lot easier because there was more bears. And then we started catching a lot of female bears. Females are really what drives the population, and they make it, they're the engine. And so we were pretty happy to see the female population doing so well, which I think was a consequence of your road management and then the huckleberries. And let's face it, some of those huckleberries were growing in old clear cuts, and some of them that's been a benefit. Often the provinces wanted to manage huckleberries by logging and hoping the berries grow up, but it doesn't do any good if the people are driving on the roads. And so it's an ineffective strategy unless what Darkwoods was doing was closing some of the roads and allowing nature to sort of grow back. There's been a really big transformation from over 30 years. Pretty cool to watch.
So Michael, when you started this research, it was quite a while ago, and there wasn't a lot known, I think, about the grizzly bears at that time. Do we know what the population was?
I started there in '99, and I DNA sampled and counted some bears. So I had a minimum count of 24, 25 bears, and we estimated, let's say 58 bears. That's include the whole South Selkirk. And then I thought 15 years later, after doing all the management we did and the research, we'd come back and look at the state of things now. We measured population size, we measured trend, was it growing? We measured number of immigrants and the distribution of females. So we got a real good sense of how healthy the populations are getting. And we've seen about a 30% increase in the bear population in the Selkirk region, and a little bit of a higher increase just within the Darkwoods area. It was nice to see it increasing.
And they're connected now.
They're connected to the bears and the Purcells through interbreeding movements and interbreeding between the populations. So those are the two big metrics we want to see: is a healthy population sort of growing or stable is good enough, but then the connectedness. So it's no longer a small isolated population.
And we're seeing that connectivity both in the radio color data and in the genetics, right?
Yeah, but mostly in the genetics, because what's really cool, often you can watch a bear move to an area, but until it breeds, it's not really a scorecard. You don't get to check that off. And the genetics allows us to show the breeding. So we have like a pedigree of all the mom, dad, and the kids. It's pretty interesting.
So Michael, you've been following these bears around for 25 years now, and so what's next for you?
The biggest thing we're doing is trying to tell this story, to spread the news. We're publishing the work in peer-reviewed journals. This has inspired an ecological corridor program well beyond bears. The importance of bears is overshadowed by the importance of the breadth of nature, biodiversity conservation, and then climate resilience. As most of your listeners probably know, biodiversity conservation is a big kind of a global crisis, as well as responding to climate change. So I'm trying to translate this work into that arena and have it be relevant. And it does seem to be working. We're getting some good traction.
Well, it sure does, and it's certainly helped us manage our properties better over the years.
One of the big punchlines is my partnership with the Nature Conservancy that's really underpinned a lot of this. They've punched way above their weight in influence, not only in the Darkwoods land, but also in the whole ecosystem. So first of all, they helped me figure the whole story out, which is really important, but also they managed their land in a way that was so good. We've sort of improved things while we're studying it and doing this large experiment. So they've been really important in the backcountry through their road management around huckleberries, and really important in the front country within the corridors where they purchased land and managed it in wildlife-friendly ways. So my relationship with Nature Conservancy has been pretty stellar, and as a scientist who has an organization with some resources to put towards that conservation, who is also listening to the science, that's what made the whole thing work. So thanks a lot, Nature Conservancy.
So I wanted to thank you very much for all your research, because it really has helped inform what we do and how we manage the properties that we do acquire and which properties to go for. So thank you very much.
Thank you. My pleasure.